Have you ever just stared up at the night sky and watched a huge fireworks display? You know, that shower of color, the crackle of the sound in the air. It's an amazing show, right? It's a blend of art and a type of chemistry called pyrotechnics. But behind all that dazzling light and sound, there's something way more fundamental going on. Yep, that's it. Every single flash of green, every burst of white, every smoky trail, it's all just a really dramatic display of matter changing from one form to another. So let's get right into it. So, in this first part, we are going to get to the very heart of what makes those fireworks and, well, everything else in the universe possible. So let's start with a big question. What is matter? Well, the definition is actually pretty simple, but it's super powerful. Matter is just anything that has mass and volume. You can think of mass as, the amount of stuff that's in an object, and volume is just how much space it takes up. Everything from a tiny grain of sand to the biggest star in the galaxy. It's all matter. Okay, so here on our planet, matter usually shows up in one of three different forms or states, and you're definitely familiar with them: solid, liquid, and gas. But what really makes them different from each other? This chart lays it out perfectly. A solid, like say an ice cube, has its own fixed shape and its own fixed volume. Then you've got a liquid, like water. It has a definite volume, sure, but it'll take the shape of whatever you pour it into. And a gas? Well, a gas is the free spirit of the group. It takes on both the shape and the volume of its container, just expanding out to fill up all the available space. But to really get what's going on, we have to zoom in. I mean, way, way in. Down to the invisible world of the tiny little particles that make up all of this matter. So what is it about this microscopic world that makes all this happen? I mean, why can you hold a rock in your hand, but you can't really hold a cloud? It all, and I mean all, comes down to how those little particles are behaving. So in a solid, picture a super crowded concert. The particles are packed in so tightly together, they're locked into place, and all they can really do is just vibrate with energy. And that rigid structure is exactly what gives solids their definite shape. Now, with a liquid, the particles are still pretty close, but they've got a little more elbow room. They can slip and slide right past each other, kind of like people moving through a busy room. And that freedom to move is exactly why liquids can flow. It's why they take the shape of their container. And a gas? Oh, the particles in a gas are like super energetic dancers who have the entire ballroom all to themselves. They are really far apart, zipping around freely in every direction. In fact, a gas is mostly just empty space, and that's why it'll always expand to fill whatever container it's in. So, this all boils down to what scientists call the particle model of matter. It really just has four key ideas. 1, everything is made of particles. 2, there are spaces between them. 3, they are always moving. And 4, they're attracted to each other. The state of matter you get just depends on the balance between that motion and that attraction. Okay, so that leads to a really important question. What's controlling all this movement? What makes the particles vibrate or slide or fly around? The answer is one word: energy. And to be more specific, we're talking about kinetic energy. That's just the energy of motion. And since all particles are always moving, that means all particles have kinetic energy. The faster they move, the more kinetic energy they've got. Simple as that. And this right here is the key idea of what's called the kinetic molecular theory. When you add energy to something, usually in the form of heat, you're basically giving its particles a boost of kinetic energy. This makes them move faster and push farther away from each other, which helps them overcome those forces of attraction we talked about. Let's watch how this works with something like gold. You start with solid gold, right? Its particles are just vibrating in place. Then, as you add heat, they vibrate faster and faster and faster until, bam, they break free. That's melting. Now you've got liquid gold. If you add even more energy, those particles start bouncing around so wildly that they just break away from each other completely and fly off as a gas. And every single substance has its own specific temperatures where these changes happen. For water, something we all know pretty well, that melting point is 0 degrees Celsius and the boiling point is 100 degrees Celsius. These are fixed, measurable properties. Okay, so we've got particles and energy creating different states of matter. So what? Why does this all matter? Well, because these fundamental rules are what give materials their unique properties, properties that we can use to build and literally shape the world around us. We call these characteristics physical properties, and they're just things we can see or measure. A substance's color, or if it can conduct electricity, or the exact temperature where it melts. Take titanium, for example. The fact that it's incredibly strong but also surprisingly light, those physical properties make it the perfect material for huge, curvy buildings like the Guggenheim Museum, but also for something as tiny and crucial as an implant in the human body. And gold isn't just for making jewelry. Its ability to resist rust and reflect heat is a physical property that's absolutely critical for coating sensitive electronics on spacecraft, like the Sojourner rover that went to Mars. Or think about tungsten. This metal has the highest melting point of any metal on the planet, and that one extreme property allows it to get heated up until it's glowing white hot, without turning into a puddle. And that's exactly what made the simple light bulb possible. So, from fireworks to spaceships, everything we create relies on understanding the properties of matter. And all those properties, they all come back to that beautiful, invisible dance of particles. So I guess the real question for you is, if you can understand that dance, what could you build?